C.A.M. Gerlach is one of the core developers of Python. He's a large contributor to the Spyder IDE, and he runs boat tours for space launches in Huntsville, Alabama. And he's going to be talking today about democratizing PyData, remote computing for all with Spyder. Here, take it away.
All righty, folks. So hopefully y'all can hear me. I'm C.A.M., as I was so ably introduced by Joshua there. So I'm going to be talking about our kind of focusing on talking about a few things we're doing with Spyder, but the biggest thing is going to be our new remote development platform, which is all open source, community developed, just like everything with Spyder, since that's what we're all about. And the sort of things you can do with it to help take advantage of all the resources that are out there today for computing, whether it's in the cloud or in your lab or on a supercomputer. So let's go. So first of all, me, a little bit more background, as I was just chatting about, I was a former atmospheric science researcher in Huntsville, Alabama, but UAH, but doing research for NASA using in Lightning and from space, basically using machine learning. But now I'm full-time in open source in Spyder and as well as Python. And I've been doing Spyder for about coming up on eight years or so. Although I've only been funded for the last 3. I used to do more of the code. Now I do a lot of the non-code stuff for Spyder, and I'm also a Python core dev doing a lot of similar things with documentation, infrastructure, and mentorship, and those sorts of things. And of course, I love my kitty cats. I got Theodore, Bagheera, Selene, and Beegers, but as a bonus was actually my 5th cat, Jan, who'll always be in my heart. He was a good kitty, so I love my kitty cats. I miss them very much, and I'm looking forward to going back and seeing them back in Huntsville soon. But my neighbors are taking good care of them. And my colleague Carlos, he's actually he's the lead developer of Spyder. He's been since well over a decade now, and leading the project. He's in Colombia. And he's also full-time in open source, mainly on Spyder. That's his full thing. And he's just like me. His background was not obviously software development. He was actually an industrial engineer. Got his PhD, so he's Dr. Cordoba now. But Spyder is his whole thing, and he did a lot of the front end, a lot of the UI for the remote development. And Hendrik did a lot of the back end. He's a newer addition to the team, but he's already made some amazing contributions just in the past couple of years. He's built a whole network back end for that, and he's really led the project, led that part of the project very well. And his background is physics. He's based in Sao Paulo, and he actually wanted to make it to. I was actually presenting here in at JupyterCon. He wanted to make it, but fortunately, visa issues with everything going on. But he also does some other cool stuff. He maintains the PyMR library, which is built on top of Spyder, and some other stuff to actually it's used all around the country and around the world, in the U.S. and internationally, in Brazil and many other countries for like MRI research and medical imaging. So it's some really cool stuff there. So, and Spyder, of course, most of you probably heard of it, but it's a Python scientific environment and IDE. I should have put a nice little screenshot there, but it's been around for about 15 years, but we've been really developing it a lot lately and adding a lot of new features, and our whole community's really come together to support Spyder, since it's not a big corporate funded project like VS Code or PyCharm. So, but we've had a lot of great community support from all around the world. Very highly international user base, and most of our developers are from outside the Western world. So it's cross-platform, and it was supported by CZI, and now by hopefully some other funding sources that we're working on as well. So, and I'll show you a little bit more about Spyder in a bit, but let's kind of go over the overall idea here. Since the talk was a little longer than expected, we're going to be talking about a few different new features in Spyder 6.1, which 6.1 was released last year. 6.1 was just released a couple months ago. So still kind of maturing those features, but the big focus is going to be on the remote development architecture and some of the features that support it, like the environment management and some of the other new capabilities. And then I'm actually going to show you how it all works live. Hopefully it works. Hopefully it's a demo and not a demo no, but like it's sci-fi. But we'll find out. So first of all, kind of the major features. Of course, the most exciting one for last. But we have our new conda-based installers, which support all 3 major platforms, and we actually helped build the infrastructure that's not only supports Spyder's installers, but also Napari and several other applications as well. And not only that, not only in 6.1, we kind of extended them further, and now they actually have a graphical updater. So you can see that, oh, look, our Spyder version's out of date. We want to update it. and it'll actually it'll update not only the Spyder itself, but it'll update the updater, and it updates the updater, and then it will update the actual Spyder, and it goes through the process. It's all graphical. I won't show you the whole thing because it takes a second, but it's all built right in. So of course you can still use Spyder with Conda, you can still use it with pip, you can use it with you can get it from GitHub, you can your distro's package manager from Homebrew, from all sorts of things. But the standalone installers kind of actually come now with their own Conda built right in, so you can actually create and manage environments without having to install anything else, which is really handy, and it also helps keep Spyder more stable too. So you can see there, Spyder's updated. We also have a very popular feature of multi-line editing support. Finally, after many years, several attempts at it, multi-line editing, you can have a column of cursors. You can add different cursors different places. You can jump between columns. You can also add individual cursors. So it's a bunch of features there. I won't go into the details there, but it's multi-cursor, what you've all been waiting for. And we also have easier support to work with different environments, because of course you can just install Spyder once, either standalone or however you choose, and then you can use it with your existing environments. They just need to have Spyder kernels installed, which is what lets Spyder do its advanced stuff like the various floor and the plots. But now we have a new menu. You can easily open a console in any environment that Spyder automatically detects, or you can add them manually. And it supports all the Conda distributions and all the standard places. It also supports PyEnv and Pixie and some other stuff too. So you can easily open a new console in any environment with just one click. And the debugger has a new stack frame browser. So of course it was already a pretty decent debugger, but now you can actually jump between your test stack frames, so the different levels of your call stack of your trace stacks, and that's where we have a whole new pane that has all that centralized. Unfortunately, I wanted to show a demo for this, but I didn't quite have the time. But it is pretty cool, especially when you're trying to debug your code and figure out why something didn't work. And we also have a new super fast search in project files. It's using ripgrep, and it's super fast. You can search your entire Spyder projects in just in just a few milliseconds. So you can then just click enter, and boom, you can launch whatever file. Just like sort of like it's Control P, just like in kind of VS Code's command window. So it works a lot like that. And there's also a new support for the, so we've had our profiler for quite a while to be able to see, what parts of your code and what individual functions are taking the most time, and maybe you can work on speeding them up. And now we actually have support in the IPython console as a IPython magic, as you might be used to from Jupyter. So it'll run in the exact same environment as your regular code. So now it's which kind of makes it run more consistently and makes sure it has all the packages it needs to work. So it's just a magic. You can just call it, and you can run it just like any other magic. And of course it'll work, but it'll display in the GUI in Spyder. So and then also a bunch of UI UX improvements. I worked a lot on this part, preferences and in preferences, and a lot of other places. All the menus we've completely reworked them, so they're trying to be as consistent as possible with the previous versions, but where it's friendlier, it makes more sense, and easier to work with. So, and my favorite improvement is the new environment and package manager in Spyder. We're still kind of ironing out some of the UI UX and some of the features, but the whole idea is then, at least with the standalone installed Spyder, you won't need to have to go to the command line or go to Anaconda Navigator to try to install. I want to install some packages. I want to create a new environment or install into your base environment. Hope you don't break something, and then I got to activate the environment, make sure you're running your code in the environment. And why didn't this import work? I'm in the wrong environment, or I installed. Yeah, I've seen so many users, so many, especially scientists and engineers and data analysts, folks who aren't, maybe their full-time job isn't managing any kind of environments. They just want to run their code and they want it to work. Struggle with package environment management in Python. I mean, we all know that struggle in one way or another. And the idea is, at least for the 90% of use cases that are the most common stuff, it'll be a lot simpler. So you'll be able to just open your project. You can create a new environment for the project, and you just tell like what the name of the environment is, what Python version, and you can it's actually in under the hood. It can support Conda and pip together because it uses Pixie, which is super fast. So you tell what packages you want to install. You hit create, and this is real time. It only takes a few seconds because it's using Pixie, which is no more waiting for Conda to solve for several minutes. And boom, you see it automatically installs everything it needs, including Spyder kernels. So you don't have to worry about managing that anymore. And then you see the environments that you have. You can have as many as you want, but you can tie them to projects. So when you activate a project, it activates the environment, it runs your code in the environment, installs stuff in the environment, everything just works. You don't have to think about it anymore. And you can edit it, and you can export your environment as a zip file. So let's say you want to use it on your work machine or your home laptop, or you want your colleague to have the exact same environment. You can have that, and actually it works cross-platform too. let's say you're on Linux and you're on Mac and you want your colleague on Windows to use it. It does not have to resolve, no more solving environment. It locks all the packages cross-platform, so it just works. And we actually take advantage of this in our remote development because it allows you to actually. What happened to my slideshow? Oops, I don't know what happened. My notes went. Come back. Come back. It doesn't want to come back. I don't know where my speaker notes went. Somehow they disappeared. Let me just start it over again. Let's try the turning it off and on again approach. Always a good one. Come back over here. All right, so we're back. Now, so those are some of the major new features that we got in our next version. But let's take a closer look at the biggest features, which I haven't talked about yet, which is our new remote development architecture. So, so of course, we all know. I mean, there's loads of cloud compute out there. Amazon, Google, Microsoft. There's tons of cloud resources out there, and there's a lot of institutions and companies have high performance computing clusters. There's also have even the machine at your desk that maybe you're at home but your lab machine at the desk has a lot more resources. You want to take advantage of those resources, right? To be able to accelerate your computation, to be able to work with larger data sets, and to be able to speed up that feedback loop between running your code and seeing the results, especially in this world of AI and machine learning where things move really fast and you want to keep up. So, but the question is, of course, especially if you're a scientist, you're an engineer, you're a researcher, right? You're maybe not the expert at HPC or at cloud stuff. How do you take advantage of these resources? Well, there's lots of different options. But it seems like it should be easy to access these resources with all the options out there. But it can still be a challenge for a lot of folks. I'm sure a lot of you here have a good grasp of it, but the average scientist maybe not. So I mean, we have this whole stack of PyData stuff, and we have all these resources out there. Some of them are even free, but it's the question of access. So there's different approaches. Of course, you can go back to the 70s and use SSH. That's what I always do. But it's doable. You can teach a researcher to do it with some work. But then things kind of become more challenging when you have to sync files back and forth in SCP or rsync and having to use the command line for teach people VI or Emacs, and it can just get pretty complex. Of course, you can rely on specific IDE to do it, like VS Code. But of course, not everyone wants to use VS Code. And you can use more complex stuff to make it easier, but then that's more time, more investment. Of course, there's also Jupyter Lab, very popular option with using Jupyter Hub. It's a pretty friendly UI UX, and it's a lot of companies like it, but it has some limitations. It's pretty much locked to notebooks only, which can do some things, but definitely not everything as you approach more complex projects and you want to transition from beyond just one notebook to something not just reproducible, but reusable across different projects. And of course, it's not really designed for software development, so if you're trying to bridge that gap between something like Jupyter, something like VS Code, there's really a gap here. And the biggest problem, and Carlos and my colleagues have urged me to mention, to emphasize this, is that it can require significant IT setup and significant resources, which really oftentimes we take that for granted in the West at our institutions, but in the global South, there's not those kind of resources to set up a whole Jupyter Lab instance. So what we wanted to do was actually provide something that independent researchers and folks at institutions that maybe don't have these resources can use to be able to get remote development working on any machine without a big technical background and a bunch of setup time. So what we came up with was called Spyder Remote Services. It's based on IPy which is based on IPy kernel and Jupyter kernels. So it works natively with Jupyter Server, and we've extended that for Spyder's needs. Using a Jupyter Server extension, which allows starting Spyder kernels, which is basically just Jupyter kernels, but with the extra stuff that allows all of Spyder's features to work, like the variable explorer and the help and the plots pane. And we also added a bunch of stuff with file system management, because the Jupyter Server API has that, but we extended it to support editing parts of files without having to download and upload the whole thing, which makes performance a lot better, and also allowing copying and moving around files with metadata and some other capabilities that we needed. And this is all split into individual modules, both on the client side and on the server side. So on the client side, it's extensible via Spyder plugins. On the server side, via Jupyter Server extensions, which are both pretty easy to install. And so you can actually, third-party developers, or let's say your institution can actually extend this to support specialized capabilities that you need for your research. So for example, we actually did this ourselves. We ate our own dog food with environment management support. So we added a Jupyter Server extension and a Spyder plugin for environment management support. And those actually communicate and and can actually manage environments on the remote host just like you can manage, just like I talked about on the locally. You can actually manage remote environments too, and I'll show you. I'll show you that in a little bit. But let's take a closer look at the client. So the client, I mean, the main job of the client that works on your local Spyder to be able to talk to and authenticate with the server. And with SSH connections, it actually installs everything it needs. All you do is put in your SSH credentials, and it will actually install the whole environment itself. It will install everything that you tell it, and of course, it'll install everything it needs to be able to talk to the remote host and use it just as if it was a local kernel running on your local Spyder. So you don't have to do any setup beyond just getting SSH working. But it also, if let's say your institution already has it, let's say a Jupyter Hub server, and they already have environments set up for you, you can also use that. It also fully supports Jupyter Hub too, and that will work with your existing managed environments. And with the Spyder Remote Service extension, which your administrator can install, it'll support all the features of Spyder as well. And on both sides, we have API modules to allow easily extending this via plugins, so you can add new remote capabilities beyond what we've already established. So, and of course, we've also I kind of went over some of the basic features we already have, but we're currently kind of fine-tuning support for full IPython Python environment management in our point versions of 6.1. And 6.2, we're working on remote editing, remote terminals, and remote projects. So we're kind of taking this a step further, and this is, again, all because of our extensible architecture, which you can also extend to, and you can actually integrate in your own applications as well. So, so now, let's actually see this in action. Hopefully it all works. Hopefully everything functions. But the overall process, just a quick overview, is you enter your credentials in SSH or Jupyter Hub. You tell what packages to install, and then you just wait for an install. It only takes a few seconds, and then you run your code. So it looks like some folks are already sending in photos from the Launchpad trip I was talking about earlier. But in any case, so let's it's demo time. So let me switch the display mode so we can both be seeing the same thing. Otherwise, it would be kind of boring because you won't see Spyder. So let's do that. And so now, this is Spyder. We've got the editor over here that shows your code. You can open as many files as you want. We have the console, so you can open, different, you can open consoles. You can open multiple and say one on a remote machine, one on a local machine, or as many as you want to be working on one thing while you're running something else. We've got the variable explorer, which I'll show you how all these panes work and the plots and everything. But so let's say here we have some weather data that we want to analyze, right? But it requires some significant computing power that we don't want to just run it on our local machine. We want to run it on our cluster. So so first of all, let's say we've created an environment via our new environment manager. You can see we have an environment here that we've created that runs our workshop that we're using locally. We can see the packages there that are installed. It shows the versions. We can modify that, but for now we're just going to leave that as it is because we know we want the exact same versions on a remote machine as we ran locally. Otherwise, our plots might look different. Our results might be different. We want it to be the same, and this will actually work. Even though I'm on a Windows machine here, I'm going to connect to a Linux machine. It actually works cross-platform. So let's export our environment. We call it Spyder Workshop. We save it. And boom, we've exported our environment locally. In the future, you'll just be able to press one button from the remote connection manager and just do it in one click. But for now, you have to export it. And now we're going to set up a new remote connection. So in this case, we're going to use we have SSH and Jupyter options. In Jupyter Hub, you just put the name, the server URL, and the token, and you'd be good to go. But we're going to use SSH for this demo. And let's call our remote server Spyder Web. And let's paste in the address. We got the port, and we enter the username. And then we just add our key file. We could also use a password as well, but for this, we're just using a key file. And if there's a passphrase, you would enter that there. Or we don't have one, don't tell. And now we tell it what environment do we want to install on the remote machine. Well, we can install more, but we're just going to do a default environment for now. So we're going to specify the environment that we just exported. And now, if we hit connect, it's going to connect to the remote machine. Hopefully everything works. Hopefully Carlos fixed it. And fingers crossed. And now it's starting up the server. So it's installing everything it needs. It's starting the server. And then it will install our environment. And now it's, yep, that's expected. And it's connecting to the server. Now it's installing the environment. And it should only take a few seconds. No waiting for Anaconda to solve it. It's using Pixie, so it's very, very fast. And there we go. Our environment was installed. That all happened in real time. So now that we're connected, and of course in the future you don't have to do any of that. All you have to do once you set up a new remote host, you just go to new console remote server, and you hit connect, and it launches just like any other console you open. It connects to the remote kernel, and boom. And let's see if we're running on a remote server. Yep, you can see we're running our remote Linux machine. So connected to our Spyder on Windows. So let's run our code. And we're going to notice something here. We're going to notice, first of all, let's switch to our working directory. But there's something missing here, and I'm going to use it to demonstrate some aspect of remote development. So look, we're missing, our module here. So wait a minute, I ran the wrong code. This was not the code. This was the code. That was the issue. That wasn't actually, I was close to the error I was looking for, but not quite. So now we're running code. We're missing a file. What happened? Well, we tried to load our data here, and let's say we need to copy our data to our remote host. In some cases, we'll have the data already on our machine, and we actually want to run our code there. But in this case, let's say our data was local, and we're missing a file on the remote host. It can be our code, it can be our data. Well, it makes it really easy. We can just hit upload, and we just go to our data here, and we select that, and boom, we're upload. This is our remote file system that we're seeing here in our file explorer. We can see our files here. We have our we have our key. We have our various code files here that were and this is the one we uploaded earlier, so our code would work. And now let's try running our code again. So supports all the same basic file operations you expect. And now it also supports the plots pane. So you can see our plots streaming over from the remote machine just as fast as they would be locally. You can see it plotted everything, our weather data quite nicely. And and then we can also see in our variable explorer, we can see all our variables. For example, if we go to this data frame, we can see this is some of the temperature data that we have and some of the different variables. And of course, this is all editable. We can edit that, and it'll actually sync the changes over. I'm not going to do it for now. I don't want to break anything, but it'll actually sync the changes over to the remote machine, just as if you were connected locally to this kernel on your local machine. And and everything works. Profiler and the plots and the files and the help all works just as if you were running Spyder directly on a supercomputer. So that's pretty much all I have for you with the demo today. And let's just go back to the end here. So that's the demo, and that's all we got. Love to take questions. But until then, happy Spydering. Actually, should have had a QR code here, but I used the wrong version of the presentation. But anyway, so questions. Put Spyder back up for you.
Very neat. Thanks. You showed how to upload a single file from local to remote. Is there some sort of syncing, like rsync-like functionality, where you might say this entire folder just replicate it or keep them in sync?
Yeah, so that's what we're working on for Spyder 6.2. We're actually working on a whole architecture for that, built on top of what Jupyter offers, so it'll take advantage of Jupyter's capabilities to do that. So yeah, in Spyder 6.2, that's exactly the main feature is syncing that. And we're actually looking to further extend that with collaborative editing support. So you can have multiple people even editing the same files and with building on top of multi-cursor and building on top of the syncing capabilities. So that's maybe that'll be 6.2, maybe the future, but yeah, that's the big plan. I mean, for now, you could also use SSHFS to do it for right now, but for 6.1 though, we are working on UX and quality of life improvements, like being able to upload a whole folder at once, or download a whole folder at once. Of course, you can also download and upload. I didn't show the downloading part, but right now that works for single files. But we'll in 6.1 in probably a point release, and maybe one or two couple months, we'll have full files and then full folder upload download, and then in 6.2 it'll be live syncing. And actually, it won't just sync the whole folder, but it will also you'll be able to edit files directly on the remote machine without having to manually sync it back and forth. You'll just be editing directly on the remote machine with in the editor. So that's what we're working on right now.
So just out of curiosity, what is the back end of the profiler and the debugger of Spyder? Is that PyData?
Yes, it's so the debugger it's built on top of IPDB, but it's we have a bunch of stuff on top of that.
Oh, it's built IPDB.
Yeah.
Okay.
For the debugger, and the profiler is built on it's been a little while. It's usually Ryan and Carlos who work on that. But that's built on top of I believe the basics of it's built off a series of Python magics and some other stuff. I can't remember exactly the details of that, but I can get back to you on that one.
Okay, thank you.
Any other questions? Anyone else have questions about Spyder, also about Python, other things?
So not a Spyder user at the moment. I just go to my remote machine and I say Jupyter Lab -- no browser and get my link and enter it in my terminal and it pops right up. But you're talking a lot about, oh, well, we use this part from Jupyter and this part from Spyder, and I'm just wondering what the relationship between the two components would be.
Yeah, so it kind of depends on the component. I mean, we actually help maintain a lot of the low-level Jupyter stuff, and we actually maintain Jupyter Q console as well. It's actually just got moved to the Spyder organization, so we work very closely with the Jupyter folks. But going to kind of the slide on that, I can give you a little bit of idea. So the core is IPy and Jupyter kernel is built on top of that, which we both kind of help maintain. And then Jupyter Server basically manages Jupyter kernels, which are built on top of IPy kernels. And then we kind of the Spyder stuff is implemented as Jupyter Server extensions on top of Jupyter Server. And then when you connect to a remote host, so you can either connect via Jupyter Hub, which manages Jupyter servers, which then manages the kernels individually, to an existing Jupyter Hub instance, or with Spyder. Spyder's our special sauce stuff we built essentially takes the place of Jupyter Hub. If you're connecting via SSH, Spyder's stuff will basically manage the Jupyter server instances, which then manage the individual kernels. So I'm not sure. And then with Jupyter Hub, all the communication is encapsulated in an HTTPS stream. With Spyder, with SSH, of course, it gets tunneled over SSH. That's kind of the high-level architecture. But if you have a more specific question, I can potentially answer or refer you to Hendrik, who unfortunately couldn't be here. He did all the network engineering on this.
No, I'm just wondering, like, if I'm already running Jupyter Lab, can I connect to Spyder at the same time, or would that just be like sort of separate Jupyter?
Yeah. So actually, you can. So it definitely works locally and actually works remotely as well So if you already have a running Jupyter Notebook or Jupyter Hub, let's say or Jupyter Lab, you can either locally or remotely, if you have the kernel file, which Jupyter exposes at the standard location, you can actually connect with Spyder to that same kernel and work with use Spyder's tools, but also have it in Jupyter Lab as well at the same time.
Say that's slower, so I can actually try it.
Yeah. It's right now we've been focusing on kind of this approach, kind of Spyder managing everything, because it's a little bit simpler for the user. But there is, we do also have a way. I believe we still support it, but there's essentially opens this dialog. You have to, so locally it's you just paste in, you just browse for the connection file of the current kernel that you're running, and it's just basically a text file that Jupyter makes that says, that lists the current kernel. You select whichever one that you're currently running, and then you just hit OK and it'll connect. Remotely, you would have to enter the same details as I showed in the other dialog, and then you would just have to tell it what you would have to find the. Usually, you have to copy over the connection file manually. Right now, we don't have a full automated solution for that, but you can. If you find it on the remote machine, you can just SCP or rsync it over, and then you only have to do it once. Then it knows what kernel it is, and then it can connect to it. So it's a little bit clunky because our main focus has been on this other approach, but that's also a possibility as well. And with Jupyter Hub, I'm not super tuned into the details, but if you already have a Jupyter Hub environment that you have you've set up on your admin has set up on the remote machine, you can connect to the same environment. Now, connecting to the same kernel, I'm not sure how easy Jupyter Hub makes that, but if Jupyter Hub makes it possible, then we should be able to do it. That part we're still kind of polishing off some of the edge cases there. So I haven't actually.
Yeah, I'll manage everything with like a pyproject.toml, and then I'll have a uv.log.
Mm-hmm. Yeah. So right now we support pyproject.toml, pixie.toml, some other older formats for managing environments. But we're definitely looking to support more formats, and I know that there's been a lot of progress on Conda's end at supporting more lock file types. So with the environment manager, you can actually import several of those file types, and it will create a new environment for you locally in Spyder. And you can also export them and use them on the remote machine. And of course, with if you already have a Jupyter environment, it'll just use that existing environment. Spyder won't need to create anything. So because it can, Jupyter will tell it what environments it has, and you'll see it just like you saw. You'll see it here in the list of remote connections. It will show you the remote environments that Jupyter Hub provides. If I was connected to a Jupyter Hub server, it would show you right there. You would just hit create, and boom, you'd have a new kernel in that environment. So of course, it wouldn't get you the same kernel that you're running in. That you're running in. Let's say you have Jupyter Hub launch, and you want to actually access that same live kernel. You could do that with the other method I showed you. It's a little more involved, but you could definitely launch in the same environment as that with just one click. So, but we'll try to make that easier in the future, because we got a couple folks who are looking for a similar workflow like that. So that's something we'll definitely be working on for the future.
Yeah, you're not going to change everything around. Yeah, but this is try it and see what this all is about.
Yeah, absolutely. Any last questions?
Do you know what is the support status for the for multi-threading for debugger and profiler in Spyder?
So right now I'm pretty sure you can only debug in the main thread without some. I believe there is a way to do it. I think Ryan was working on a way to do it, but I'm not sure how much progress has been made on that. But that's definitely something that we can take a look at in the future.
All right, well, let's thank the speaker one more time.
Thank you for coming. I appreciate it.